Hello friends, in this video we will discuss various important rearrangement reactions in organic. Hello friends, now we will discuss second rearrangement, that is Pinacol-Pinacolone rearrangement. Now statement of this rearrangement is, it is acid catalyzed rearrangement of vicinal diols or 1,2-glycols to aldehyde or ketone is called as Pinacol-Pinacolone rearrangement. Now first of all, let's understand the general structure of this rearrangement. Vicinal diols are the structures which have 2-hydroxyl group present on neighboring carbon atoms are called as vicinal diols. Now this hydroxyl group are present on two separate carbons which are present nearby to each other or adjacent to each other. So such structures are called as 1,2-glycols or vicinal diols. Now these on acid catalyzed rearrangement are converted into aldehydes or ketones. So it will be double bond O, C, R2, R3, R4. So this can be an aldehyde or a ketone. So this name is originated from the classical example of conversion of Pinacol to Pinacolone. Now what is structure of Pinacol? That is CH3. This is Pinacol. 4 methyl groups are present in this structure and 2 vicinal alcohols. Now it is in presence of an acid is converted into Pinacolone. CH3, CH3, CH3. Now from this classical example, this rearrangement is termed as or is called as Pinacol-Pinacolone rearrangement. Now in this particular rearrangement, migrating group, it can be a methyl group. That means it can be an alkyl, it can be aryl, it can be you can say ester group, or sometimes it can be a hydrogen. Now this migratory aptitude depends on the reaction condition or maybe just because of some special feature which we'll discuss later on. But first of all, let's understand the mechanism of this particular rearrangement reaction. Now step 1 of this rearrangement will be, now as this rearrangement is taking place in presence of acid, so there is attack of proton, which this proton is coming from acid. So R1, C, R2, C, R3, R4. This proton will attack on any of these 2 hydroxyl group to convert them into a better leaving group. Now in this case, better leaving group will be a water molecule. So suppose in this case this proton is attacking on this hydroxyl group and it is converted into a water molecule which will be the better leaving group in this case, OH2, and this positive charge. So this hydrogen or this water molecule is released from this structure and this carbon will get a positive charge. So formation of a carbocation take place after attack of a proton and release of water molecule from this structure. Now in this particular case, the rearrangement take place just to stabilize this carbon or to stabilize the positive charge on this carbon, for which one of the alkyl group or aryl group present on neighboring carbon migrate to this carbocation. So that is our second step, that is rearrangement. This rearrangement takes place just to stabilize the carbocation. So second step will be R1 C, R2 C, R3 R4. Now this is positively charged. This contains an hydroxyl group. Suppose in this case this R2 is migrating from the neighboring carbon to carbocation. This is called as carbon 1,2 shift or carbon-carbon shift. Now this will give R1 C, R1 R2 R3 R4. This is hydroxyl group and this gets a positive charge. Okay, now this migration has happened, or this migration has taken place, but every time after getting a positive charge, this positive charge on carbon is, you can say, stabilized by resonance stabilization or resonance structure. R1 C double bond O H. Now this high oxygen will get positive charge, and this is how this structure is stabilized, but not for a long time. This is just, you can say, adjustment. So this is how the positive charge on carbon is, you can say, adjusted, and that's the reason why migration has taken place. Because in the previous case this positive charge is present on this carbon, which was, there is no way to stabilize it. But if this charge is shifted on the neighboring carbon, which contain an hydroxyl group, can be stabilized by a resonance structure. So that will be, or that is the driving force for this rearrangement. That is, resonance stabilization of this positive charge is the driving force for this particular step or for this particular rearrangement. Now after migration or after resonance stabilization, this hydroxyl group, it easily loses. That is our step and you can say step 3 in rearrangement, that is loss of proton. This proton is lost from this hydroxyl group to give a more stable structure, that is aldehyde, or that can be ketone. R3 R4 R2. So this is our final structure. That is how this is how we are getting aldehyde or ketone. Now as far as this rearrangement is concerned, we have just understood why this rearrangement has taken place. This is just because, or the driving force for this rearrangement is resonance stabilization of the proton, or you can say positive charge drives or is acting as driving force for migration of any of the alkyl group present on the neighboring carbon to carbocation. So let's see what are the features of this rearrangement. Now this rearrangement is completely intramolecular rearrangement, which is proved by, you can say this statement can be supported by the migration of, suppose in our 1,2-glycol or vicinal diol there is a chiral carbon. Now this is an intramolecular rearrangement reaction, just because migrating group, if it is a chiral carbon, it retains its configuration. So there is retention of configuration. This is why, this is how we can support our statement. The second support is given by formation of no crossover product. If we are using two different vicinal diols in the same reaction vessel, then there is no crossover product. So this is, or this can be, a completely intramolecular rearrangement reaction. Intramolecular, just because first support is given by chiral carbon. Now let's see what are the features of this Pinacol-Pinacolone rearrangement. First is regarding migratory aptitude. Now, as we know what is migratory aptitude of this, what is migratory aptitude? Migratory aptitude is a tendency, or simply tendency of any group or atom to migrate or to change its position from one place or one atom to another atom. It's just a tendency. Now, this tendency depends on, as far as Pinacol-Pinacolone rearrangement is concerned, this tendency of migration depends on probably reaction condition. Reaction condition. Suppose, for example, let's see, this is our Pinacol structure, which is unsymmetrically substituted Pinacol. Unsymmetrical. This carbon contains 2 hydrogens, this carbon contains 2 phenyl rings, and we carry out the Pinacol-Pinacolone rearrangement reaction by using acid. Now the question is, may arise, which of the hydroxyl group among these two will get protonated? Now suppose we have 2 hydroxyl group, that means we have 2 carbocations. First condition will see, this carbocation will form after loss of water molecule. Suppose this hydroxyl group is attacked by proton and it is lost as water molecule, so this carbocation we will get. And in second case, the proton attack on this hydroxyl group and it is lost as water molecule, so this is what we are getting in this second case. Now, which among these two carbocation is more stable? It is simply understood by the stability of carbocation. Tertiary carbocations are more stable than secondary carbocations and then primary carbocations. This is their trend of stability. Now in this case, this is the tertiary carbocation, so this will be more stable. This is a primary carbocation, so it will be less stable. So the hydroxyl group will be attacked by the proton and is lost as a water molecule, or it is lost as a water molecule to form a more stable carbocation. So among these two steps, or among these two cases, this is the only carbocation which will be formed, but this carbocation, as it is less stable, it will not be formed. So this Pinacol is converted by this path into, or the second step will be, this proton will migrate from this carbon to carbocation to give aldehyde. So you will get this, if this is your starting compound, then you will get aldehyde in this case, but you will not get ketone in this structure. This pH will migrate So this is not the product we are getting after Pinacol-Pinacolone rearrangement of this particular structure. This is the product we are getting. This is just because of the intermediate structure, that is stability of carbocation. So this is the important factor, or this is the important parameter of Pinacol-Pinacolone rearrangement, that is migratory aptitude. So this Pinacol-Pinacolone rearrangement can be used for synthesis or for synthesizing various aldehydes or ketones from vicinal diols. So this is in short about Pinacol-Pinacolone rearrangement. Thank you for watching. If you have any suggestions, please contact me on sdkulkarni99@gmail.com. Thank you.